In this video, we are going to deal with this section. That is this dark section in the middle of these light sections. So to do that, we're going to need to solve a couple of problems. We need a way to define colors that are inverted from the natural semantic colors. We need to be able to place a background on a section, and we need our cells to have the right color for the text when it's over a dark background. So the first thing we're going to do is define some semantic colors that are inverted from the natural versions. There are a bunch of different ways we could solve this problem, but in going through this, I landed on something that I really like, and that is to add a couple of extensions. So the first thing we need to do is add a new extension on UITraitCollection. What we're going to do here is define a couple of styles. So first we're going to have this private static style called light style. So we're going to have a light style and we're going to have a dark style, which will be the same thing, but dark. So what this is a UI trait collection with the default of everything else, all the other traits. But the user interface style is light, the user interface style is dark for this one. Those are both private. So we're going to add a function on UI trait collection called inverted style, which returns UI trait collection. We're going to switch on the current user interface style. And if it is dark, we're going to return a new UI trait collection. From using this initializer called traits from, which is really convenient. So we're going to pass in self and we're going to pass in the light style. Now what this initializer does is it returns a new trait collection consisting of all the traits merged from a specific array of trait collections. So it takes an array of one or more trait collections and merges them to make a new trait collection. And if it contains more than one element, the highest indexed element that contains a given trait is used for that trait. So here we have a trait collection that just defines the light style. So we're going to use all of the traits from whatever trait collection we're in, and we're going to override the style to be light style if it is currently dark. Then we need another case. So if it is light mode, or let's say unspecified, because that usually means light, we're going to return the same thing, but with dark style. Then we need to have an unknown default case. And in this case, we'll just return self. It won't actually be inverted in that case, but if we're not dealing with light or dark mode, I'm not sure how to handle it currently, so we're just going to return the current UI trait collection. Okay, so what that allows us to do is anywhere we care to look at a trait collection and get the opposite user interface style, we can just grab it with this inverted style function. So now let's define some colors on UI color, and we'll use that. Except let's name this plus inverted. Need to import UIKit. This will be an extension on UI color. We're going to define a inverted background. And what that is going to do is, I'm not going to define it that way. I'm going to define it this way, UI color. So UI color has an initializer that takes a closure, and the closure gives us a trait collection. So what we're going to do is give the system background, there it is, the resolved color. It has a resolved color with the trait collection, and the trait collection we're going to use as traits with the inverted style. And we're going to do the same thing with label. Oh, it's not system, it's just label. So now we have versions of the system background and system label colors that are inverted. So if we're in light mode, this will give us the label color for dark mode. And if we're in light mode, this will give us the background color for dark mode, whatever the opposite of the one that we're in is. So now let's use them. First, I'm going to define a style here. Color style, which is going to have two cases, standard and inverted. We'll use those in a minute. Then in our large square cell, I guess in our large square view actually, we're going to have a private lazy variable style, which is a color style. And that's going to equal the result of this provide style function, which we're about to write. Doesn't exist yet. Throw it down here at the bottom. There we go. Sorry for my inability to type. All that's going to do is return standard for this case, and then we need to actually use it. So in configure, here we're going to grab a text color. So we're going to say let text color equal style equals dot inverted. We'll return the inverted label. Otherwise, we'll return that label color. Then here, instead of making this label, we'll make this text color. We'll make this text color. So there we go. So now our large square view has a style property, which it provides. And then in configure, we'll look at that style, and if it's inverted, we'll use inverted label. If it's not inverted, we'll use the label color for our two labels. And you're probably asking yourself, why are we doing it this way? And it is so we can use inheritance to not have to rewrite any of the rest of this code. So now all we need to do is add a class called inverted large square view, which is a large, inherits from large square view. So this is a subclass of this view class. And all we need to do is override provide style. and have that return dot inverted. Then we need a cell that will use it, so we're going to add a new type alias. Called inverted large square cell, which is a content cell with an inverted large square view. There we go. Now we have a cell. We only had to add a little bit of code. And then we're going to do the exact same thing for the header. So if we go to the content header, in the section header view, let's add our provide style function. Then we're going to have a private lazy var style, which is a color style, which equals provide style. Then we'll have the same text color. We'll use that text color here and here. Then we need to make an inverted header, which we can do pretty easily by saying final class inverted header view. The section header view. We're going to override provide style and have that return inverted. That takes care of that. And we need a type alias. There you go. Okay, now we have inverted versions of both our header section and our large square cell section. And we have a pretty easy method for adding it to other cells if we need to. Now what we need to do is have a way of adding a background to a section in our collection view. In UI collection views, we do that with a decorator item, which needs to be a subclass of UI collection reusable view. We're going to do a similar subclassing thing with that because it'll make it easier to add the background for the footer section. So first we're going to define a background view class to be a parent for all the backgrounds. So we need to add a new file. It's going to be called background view. We need to import UIKit. So this will be background view. It's going to be a UI collection reusable view. We need to override the init from frame, call super.init with that frame. And then we need to set our background color. So here we're going to have a function called provide background color, which returns a UI color. And by default returns nil, which we can actually write like this. So then in our initializer, we're just going to say background color equals provide background color. Then the compiler will complain that we need the required initializer. Here again, we can call super.init encoder and say background color equals provide background color. Cool. That's all we need in the super class. So let's define our inverted version. And all that is doing is returning the inverted background color that we just defined earlier as the background color for this background. Now we're going to add some helpers that make things a little more convenient to actually use these backgrounds. First thing we're going to do is define another enum called background style. It's going to have a raw value of string, and it's going to be case iterable. We're only going to have one case for now, but we can easily add cases down the line this way. We're going to have this inverted case. It needs to have two properties. One is going to be the element kind, which is a string. And for that, we're going to return the back. We're just going to say this is a background dot raw value. This dot syntax makes it a little more safe in case we have inverted used in other element kinds for our reusable views. And then we need a view class property, which is going to be any class. And then here is where we're going to map our case to a type. So when our background style is dot inverted, we need to return the class that we want to use is inverted background view dot self. And that's pretty much all we need to do there. Now on UITraitCollection view layout, we're going to add an extension to register the backgrounds, because you can't use registrations for decorator views like you can with cells or headers. We have to register these types with the collection view layout. So to make that easier, we're just going to add this extension called UITraitCollection view layout with a function called register backgrounds. And we're going to go through our background style, all cases for each. We are going to register the view class for this background style with the string $0.element_kind. So it's going to loop through, and it's going to, whatever type it gets for the view class, it will register that type with this string, background.raw value. Then finally, we are going to add a convenience extension on NS collection layout section called add background style. Here what we're going to do is in this section, we have this array of decorator items. We're going to append a background with the element kind style dot element kind, because that's what we passed in. So then in our section, all we have to do is call add background and tell it what style of background we want, and that'll be in our decoration items, as long as we remember to register the backgrounds with the layout. So now we actually need to use these views in a section somewhere. In our section definitions, we're going to add a new static function, a new section type called inverted side scrolling one item. And here, it's going to look exactly the same as the side scrolling one, so we can just get our section from there. we can add the background. And then we can return it. Then in our make collection view function, in our switch on section, we can use that new section type. We're going to use it for the experiences section. We're going to return inverted side scrolling one item. Which I'm not getting an autocomplete because I haven't built recently, but it works. And then here we also, before we return, we need to say layout.register backgrounds. Otherwise it's going to crash when we try to use it. Then we need to update our data source. Switch on the section here for experiences, which actually, let's just run it right now and see how it looks. Right now, so we're using the inverted background, but we're not using the inverted cells. So what we should see is that it renders correctly, except the text is still black because it's using the default for those cells. So the background is there. We're seeing that. That's good. But to see the right cell, we need to tell it to use the right cell. Here we're going to say let regis equal inverted large square cell dot registration, and then we're going to return the view using that registration. So now if we run it, we should see the right thing in the cells, but not for the header. Invisible header, right thing in the cell. So now we need to update this supplementary view provider closure. We have our header registration. Let's grab an inverted header registration. And then in here, instead of just using the header registration always, we need to look up our section. We can switch on that. And if it is experiences, we want to use the inverted header registration. Otherwise, we want to use the regular header registration. And there we go. Let's try running it now. Oh, missing a return. Oh. Need to add returns in here. Cool. Now when we run it, we have our dark background. We can read all the labels. That's looking good. And if we flip it to dark mode, it inverts. So now all the other sections are dark, still readable, and this section is light. So it still stands out just as much as it did before, but it is inverted. Now, it should be noted that the actual Airbnb app does not handle dark mode currently, or at least not the last time I tried it. So hopefully they will steal some of these ideas. So there you go. In this video, we looked at a couple of extensions to make inverting colors a little easier, but still having variants for both light and dark mode. We looked at how to add backgrounds to the collection view section, and then we used them. So in the next section, we will add the footer, the last little section here, and we'll add a new background and have some fun with these separators. So I'll see you there.